Hello and welcome to the third of the digital twin webinars from us at SurveyTech. And thank you very much for joining us. We're still having a few stragglers come in, so I guess a little bit of housekeeping. We will have questions after the presentations from our speakers. So if you have anything that occurs to you as they're speaking, please do put your questions into the interface, and we'll ask them afterwards. We'd really like it to be a sort of as interactive as possible. So if anything occurs to the speakers and they want to put it to each other, then please do. So with that, I think we'll get started, and I'd like to introduce briefly our guests for today. We have three people that the internet are calling the dream team of laser scanning. So we've got Chris Atkinson, who'll be speaking about Matterport, Charlie Crock, who will be telling us all about GeoSLAM, and Phil Marsh, who will be speaking about the Leica Geosystems range of products. And so I'll let you maybe introduce yourselves and how you came into reality capture and laser scanning. If we start with you, Phil.
Okay, thanks, Matt. So welcome everyone. My name's Phil Marsh, and I'm the reality capture manager for Leica Geosystems, which is part of Hexagon. I've been with the Hexagon sort of company for the last 12 years. I've been in the survey industry for about 26 or 27 years, so quite well versed with sort of terrestrial and everything about surveying. Passionate about 3D laser scanning, and I founded the Laser Scanning Forum in about 2007, I think. So yeah, it's been going good. So yeah, that's me.
And then Charlie.
Hi everyone. So yes, I'm Charlie Crock. I have also been in the survey world for quite a number of years. Got into survey back in 1999 and was fortunate to be coming out of university just at the right time when 3D laser scanning was sort of commercially hitting the market. So I've been working in and around point cloud technology since about 2002, 2003. I'm now working with SurveyMax, and we are the dealer partner for GeoSLAM here in the UK.
And finally, Chris.
Great, thanks. Yes, my name's Chris Atkinson. I'm the AEC specialist here at Matterport. My background's a little bit different. I was actually an architectural technician to start with, working on projects, delivering building information models. And after a little while, I managed to get my hands on some light scanning and really got the bug from there. It is a technology that is quite hands-on, and I'm quite techie myself, so I always appreciated the opportunity to get out of the office with a scanner and have a go. So I've kind of moved from that sense through some of the high-end providers who provide high-end accurate laser scanners before finding my way to Matterport. So yeah, just a quick nutshell.
Okay, brilliant. So I'm going to start off with a very short presentation because, to be honest, I want to get on and see what you guys have to say. But just briefly, I think I'd like to just show this photo from, I say photo, it's a daguerreotype from 1838. And it's one that I started this series of webinars with. So in 1838, this technology arrived, and suddenly we were able to take the 3D and make it 2D, and it was quite a profound change. And actually, we're kind of going through the same thing right now, except we are capturing the 3D and preserving some of its three-dimensional characteristics, and that really is what it's all about in terms of reality capture. So it's a really interesting time to be involved in this technology, and just like the photograph completely changed, so many different industries, we'll find that reality capture will be pretty transformational in a lot of other circumstances. And from the profound to the ridiculous, this is just one of the fun and creative things that is happening with reality capture technology. Our guest on our last webinar developed a zombie game where you can put in your own Matterport scans and you can survive the zombie apocalypse, and it's just completely ready. I mean, there are so many creative and practical outlets for this technology that I'm really pleased that we're going to be able to kind of share it. So yeah, here are some definitions, because sometimes words can be thrown around, and I think it's useful to lay down a glossary first of all. So yeah, reality capture, like I was saying, it's keeping those 3 dimensions, and there are different techniques for that. So photogrammetry is being able to take the measurements off of a photograph. LiDAR, obviously we're very familiar with sonar, radar, and LiDAR is the same, except they're using light. And I've got a little picture in the bottom right corner of how LiDAR essentially works and creates those point clouds. And I think it's kind of easier to look at it visually. I'm sure we're going to have lots of point clouds after this, but fundamentally it's kind of mapping out a series of discrete points in space using a laser. And then BIM, building information modeling. Now, this is something that people have whole conferences about and is a bit of a buzzword, but I think it's useful to think of really as everyone singing from the same digital hymn sheet, and it can be kind of simplified or complicated depending on your usage, but really a lot of it is about digital construction, and then obviously the digital twin. I think when we talk about the digital twin, I think it's worth saying that we've done 2 whole webinars on this, and one of the crucial points about a digital twin is that you create the digital twin and then that interacts with real life and allows you to operate whatever it is better. So it's about doing that laser scan and then using that data to create whatever it is that you want to, and it being a sort of loop rather than a one-way digital shadow. And finally, a bit of a plug for some of our technology videos. All of the both these webinars and we have discrete videos about each of the technologies that you'll see presented in this webinar, and they're all on our YouTube page. So just search Survey Tech. Okay, well, with that said, I'm going to pass over to Chris Atkinson. And the other thing to say is all of these technologies are available from Survey Tech. There's an old phrase, to the man with a hammer, every problem looks like a nail. And I think we try to allow people to understand that there are more tools than just the hammer, and help you to, find the best technology based on the outcome that you want. And we use these experts to filter that knowledge and hopefully help you. So with that said, I'm going to pass over to Chris Atkinson. So Chris.
Yep, thanks very much, Matt. I'll just share my screen here and bring the screen up. So yeah, thanks for taking the time to let me discuss Matterport with you today. So I just want to give you a little bit of an insight in terms of Matterport, what it does, where it fits, but I also want to kind of set the scene a little. I think the slide you're kind of seeing at the moment is a real impact statement. I heard this a couple of years ago when I attended Autodesk University, but the virtual version, because we were obviously within the height of the pandemic. So if we read that slowly, 90% of all data in history has been collected since 2019. Now, that's quite phenomenal when we think about it. But in reality, this doesn't show any sign of slowing down. It's only going to get more. We're collecting so much data, and we've made it so easy to collect data now that there is an argument in a case here that we're going the opposite way. We're not being as efficient as what we should be, and we're actually becoming data hoarders as such. So the difficult part is often about filtering through to find the data that is important to us on our projects. Now, my background in construction has always come from kind of, how are we using the data? How are we being efficient with it? What is the workflow that the scan data will go through to achieve our final goal? And we can see from this that despite us collecting this massive amount of data, we're still continuing to be inefficient with it. The sending point clouds to customers actually has a reliance on that customer or that person in the design team, that they know their software well enough, that they are able to operate and understand what they are looking for to spot that same issue. And that often leads to miscommunication between it. But the great thing about the laser scanning element of this and what we're talking about is you don't miss a lot, if not anything. You're used to going with your tape measures and measuring up. This thing will fire 1 million measurements a second, so you're not missing anything. But I really do think that we need to look at how we understand that information. The data side of it is really easy now. Gone are the days of only a surveyor coming to site to do the scanning. Yes, they are very skilled. There are certain procedures where they are the person to come in and do it, but laser scanning is a much more open field now, and a lot more people can do it. The firms that we've got on here have made it so easy to actually capture the data. It's simply click a button half the time and move out the way so you're not in the scan data. So the data side is really easy. But for me, the emphasis is on this ingestion side. It's on the understanding of the data that we're actually collecting and finding the information that's important to then communicate with the others in the team so that issues can be resolved more efficiently and faster. And that's where we start to see the benefit from this. So just as a little example, if you haven't seen Matterport before, Matterport are a company that are about 12 years old now, and we've often been considered predominantly in markets such as residential real estate. You may go onto a website and you might see a virtual tour of a home that you may want to purchase. That's usually done by Matterport. This very hands-on experience where you kind of walk around, click where you want to go. So it really is quite unique, but it's extremely versatile. We work in a lot of different industries, everything from residential real estate to travel and hospitality, commercial real estate, and even into AEC as well. But as you can see, it gives you the ability to overlay your 4K imagery with essentially your mesh or your point cloud, and move around that in a URL, essentially a cloud hosted version. So it's accessible by anybody in the design team, no matter where you are around the globe. But as I said, there are many use cases for technologies like this. So don't just think as a laser scan for using measurements and taking measurements. It's for a lot more than that. And we can see just a very brief outline there of some of the teams in a project that could benefit from having that digital twin, that representation which is captured by the camera of the scanner. The design element right up front, we may be looking at how we retrofit or renovate a particular environment, or maybe even extend to it. We need to understand the existing environment in a lot of detail. We need to understand the risks, the condition of that building before we start building it out. And there's no better way to do that than looking through laser scans. You can see some of the other elements on there in terms of capturing the build of the site on a regular basis, documenting that site so that we do have a representation of what happened at that time, a nice stamp point And again, those can be used for archiving and for referring back to, should we need to know what was actually installed behind this wall. One of the main use cases that Matterport have had in the past is this marketing and sales, this promotional use case, trying to encourage people to either purchase that house or book their reservation at this hotel or restaurant. But that even works for construction as well. I mean, if you think about an architect, their end product is the design of the building, bringing it from digital to real life. So they should be marketing and promoting that through something like Matterport. The contractor themselves will want to promote the quality of their work, as well as documenting that, as we've stated. So lots of use cases through many different teams in the organization. Just to highlight a little bit more on some of those use cases, we can kind of see that project lifecycle very basically broke down into your existing, your initial design state, and then the building and the handover of that. And these are some of the tasks that where not only Matterport can be used for that, but laser scanning and the technology just in general. I mentioned design risk assessments and condition surveys. You know, we're used to handing over PDF reports or documents with hundreds of pages and thousands of photographs in, and it really becomes difficult to filter through and find those that are actually going to have a prominent impact on the design of the building. If we're offering the data in a much more accessible way, it makes it easier to ingest, to understand. As we move through, you've got things like the deliverables that we export out from our platforms. So again, not only having the showcase viewer where you can walk around your virtual tour, but taking that point cloud data out as, say, an E57 or an RCP, an XYZ, or even the mesh file formats in OBJ. As we look towards that final handover stage, again, what we're handing over to the building owner is essentially the perfect time to do a scan. You know, before the doors open and people start coming in, this is the part in time where not only the architect is benefiting from promoting his design, the contractor has a documented version of the site, what he has handed over prior to snagging. But the building owner can use it as a promotional asset as well. And we often see a lot of companies and facilities managers using the Matterport environment as a training asset to allow people to understand their work environment and train them through the bits of equipment they might be using in the future. So one thing I'm a firm believer of, and it's great to have obviously the other speakers on this at the moment, is that all scanners are not the same. There's always the comparison between brands and how does your scanner compare to this scanner. They're designed with different purposes in mind. And I think choosing the right tool for the job is a real emphasis on here. So ask the right questions to understand what camera you're going to use at the front, what scanner you might use, and the data flow as we go through. Which pieces of software is that data going to be going through, and what is the purpose of the data going through, to make sure that you actually are using that right tool. I think one of the things here at Matterport that we pride ourselves on a little bit is our camera ubiquity strategy. The idea that you will always have at hand an item or a camera where you can capture a Matterport space. And that starts as basic as the camera in your pocket, which is really great. Whilst you're not going to get as accurate data from that, it's still going to give you a digital reflection of the entire environment. And it's really, really easy to use. So if you haven't, I suggest downloading the Matterport app, signing up for the free account and giving it a whirl. As you go up the list, you start to get into higher accuracies. You start to get into a slightly more cost depending on it. And the two cameras that I'll just pull out here are the Matterport Pro 2, which is an infrared camera. Infrared technology being different to LiDAR. It has its pros and cons in each. But also our Matterport Pro 3, which is the camera we released at the back end of last year, which is our LiDAR laser scanner. So just to highlight a little bit on that, LiDAR is typically the norm in AEC, and obviously the other brands here today do have LiDAR scanners available. And again, it's a case of LiDAR is extremely powerful in terms of capturing data indoor and outdoors. The LiDAR is not affected by, say, sunlight like the infrared might be. Accuracies tend to get a lot improved. And again, it gives you that real flexibility, that ability to literally put your camera in an environment, hit go, and capture millions and millions of data points. Now, as you capture an environment, the second part of this is about the deliverables and what we kind of offer, how that workflow goes through the stream from one to the other. So I just wanted to highlight a few. I mean, the automated showcase viewer that is presented to a customer has a number of tools in, things like being able to measure, being able to look at the floor plans, being able to cut sections through the property, and actually tagging elements in there. They're all there in a standard deliverable that we provide to you. But there are those file formats that you will want to take out and go further. So typically those are your point cloud formats, your mesh files. And those are usually used to start the scan to BIM process, the process of essentially translating a point cloud or tracing over it and turning it into a building information model. Now, one of those things on there, and one of the items that I'd like to talk about a little bit more in detail, is that scan to BIM. I did it in practice, and I must admit I went to university and I didn't train to do a color by numbers job, tracing over the top of a point cloud. My time could be spent more efficiently. The design team's time could be spent more efficiently doing design related tasks that are more prominent. So what Matterport have actually released as part of one of our deliverable options is a service that will convert your point cloud to a building information model file. Now that is an Autodesk Revit supported file, but we also provide the IFC file format as well, which is software neutral. And this really does give you the LOD 200 kind of starting point to then evolve and layer and add information to that as you go through. So just in summary, there's a lot of opportunity with scanning. It is a process that is becoming simpler. As I mentioned before, the data element is getting easier to do, but we need to understand our requirements on a job. We need to understand what we're doing with the data and how it travels. And I hope that's been useful to you. There is a link on the bottom right corner there if you want to have a look at a Matterport space and have a dive into some of it. There's thousands of example spaces on there, so please do so. And with that, I'll look to change over to Charlie from Geomax.
Thanks, Chris. I thoroughly recommend that Matterport Discover page. It's you can find yourself walking around a sort of haunted house, and then an ancient Egyptian archaeological dig. Charlie, we can see your notes in the next
you got
slide.
my other way around.
Yeah.
Let's swap them around.
So yeah, definitely recommend.
Is that better?
That's better. Yeah.
Perfect.
Okay. Thanks, Charlie.
Fantastic. No, thank
you've
you.
got a cat as well.
Oh God, yeah. Sorry, I don't possess a tail. I do have a cat sitting on my lap at the moment. So they have no manners when it comes to being on Teams calls or anything like that. But anyway, thank you, Matt, for obviously giving us the opportunity to come along today. I'm here representing GeoSLAM. So I work for SurveyMox. So we are the UK main dealer importer of GeoMax products, but we're also in the UK we're the main dealer for GeoSLAM products as well. So we've my background, as I mentioned earlier on, I've been working now with Point Cloud since about 2002, 2003, when they first commercially came on the market. The technology was available, and I was very fortunate to get in at that very early stage. And it's been a fascinating sort of journey to see the technology transition from very, very, dare I say it, primitive initial data capture tools right through to where we are now with mobile devices. I've had primarily my experiences when I was working on the tools as a surveyor was within the sort of tripod world of scanning, so the static world. But with GeoSLAM, obviously our primary focus is within this mobile capture, so being able to use handheld technology, handheld LiDAR to map the spaces. So yeah, it's an interesting application base, and we're starting very much to see a transitional shift in uptake of GeoSLAM and SLAM technology generally, and seeing it fitting in and being very complementary to tripod-based systems. So for those of the uninitiated in the market, we'll have a quick look and dig into what SLAM is essentially. So SLAM is your simultaneous localization and mapping. So what we're doing is we are constantly viewing and mapping and using geometry objects within that scan data to be able to obviously, within that view of the scanner, to be able to form and position and create mapping technology. There's some real key benefits with and where we're seeing strong application base of SLAM technology. It is an incredibly rapid way of capturing data. We're able to essentially, as fast as we can walk steadily through a building, we are also digitizing that space, and we're capturing 3D coordinate point information. It's very simple. So we have a lot of non-survey users being able to adopt GeoSLAM and SLAM-based technology applications very, very rapidly, which lends itself to MOD applications, and police forensics applications. But we do also obviously have this niche within the survey community as well, which fits in with the tripod-based systems. And the versatility, we can map pretty much anything with the systems. There's two primary technology hardware functions that we have with two different, a shorter range solution and a longer range solution. We'll talk about those a little bit later on. But with the longer range solution, we're not just an indoor mapping tool. We're seeing it extensively being used on backpacks, vehicle mounted solution, as well as obviously still the handheld mapping ability as well. So how does SLAM technology work? And as I said, we're robust in how we capture. The visibility of the scanners is key. It sees what you see as you move around that space, and provided you give the technology the ability to see and view what you can see, then we're constantly mapping, and we're using all of that geometry that we're capturing to be able to unravel and process our SLAM data. But the key for us is being robust in our capture. We can see that as we walk around, we form loops within the data, and that gives our SLAM trajectory rigidity, and it gives it structure, and that improves the quality of our data. Early systems, drift was a common factor where it didn't quite have that ability to be able to fix itself and move and use existing data. But now obviously we've got 16 sensors within the Horizon scanner, and all of those sensors come together to help us produce a nice robust data set. And as you can see, we are in that walkthrough. So we end up with our red line, our trajectory line, which is nice and repetitive. We've got commonality as we move around that building. But what underpins the GeoSLAM technology is the beam, the GeoSLAM beam algorithms. This is the software base that actually does that complex unraveling of our data. So with mobile technology, the scan head itself rotates as we're capturing, and it has a walk line to our trajectory file. And what the technology, this algorithm is doing is essentially unraveling that helicoid of data from being a spiral to being actually what we would recognize as a traditional point cloud. So the beam algorithm has been enhanced and developed, and the new version of GeoSLAM Beam, which is in the latest release of GeoSLAM Connect, is a really, really strong offering on the market. It's robust, it's reliable. We've got data sets that are processing with great accuracy that previously may not have processed particularly well. So those enhancements obviously improve the confidence and the application base of use of SLAM technology in the market. So what is the key differences then between the static market and the mobile market? So obviously tripod-based systems, we work on line of sight data capture. Mobile systems, we go everywhere with the scanner, so we are constantly capturing as we walk and move through those spaces. So a quick example here. So with static scanning, the little orange dots that you can see within this building floor plan essentially represent every single tripod location. So we've located our scan, we've taken our measurements, we've done that scan, we've moved to the next location. And we can see that to do this building properly, we've got somewhere in the region of 125 different scan positions, which then we can do this in a degree of automation, but those scans need to be positioned together to form this overall representation of our space. We're a little bit more accurate when we come to tripod-based scanning because we are sat still, so that, you know, there's less variables to play with when we're talking about the accuracy, but there's a trade-off with that, and that is the processing and actually the actual data capture time out on site. When we look at mobile scanning in comparison, we're far faster. So that speed and that access means that we can go into more spaces, we can cover ground more quickly, which in certain applications obviously is quite crucial. Being able to get in and out, we don't want to be too disruptive when we're capturing and going into, say, residential or office spaces. We do, with that speed, we do obviously compromise a little bit on the accuracy, but not in, you know, it's not a significant amount. We're sort of in the region of, you know, 5 to 10 millimeters on the local accuracy and 1 to 3 centimeters, and that's versus probably sort of 2 to 5 mil, depending on which application, which hardware sensor you're using from a tripod base. But obviously that global accuracy is a little bit lower overall. But a very, very strong offering, you know, in terms of speed versus accuracy. In my many years of laser scanning, we've always had that that compromise or that degree of where do we focus our efforts on? Is it the amount of data we're capturing? Is it how long we've taken to capture that data? Is it the resolution we're capturing at? And is it, you know, the accuracy of that resultant data set? And there's many factors that go into all of those that we have to weigh up to find the best solution. And there is no one tool fits all. And that's increasingly what we're seeing in the market is sort of hybrid data sets. So being able to combine your GSLAM data set, your mobile data set with tripod-based systems, with survey networks, with GNSS. And all of that gives you a robust offering and a robust deliverable back to your clients. So from a GSLAM perspective, we've got the ZEB family of scanners. And the focus really is from GSLAM is in this. We do our data capture, we process out that data in GSLAM Connect. We can view and obviously make sure that we're happy with that data set and the accuracy and the tolerances are there. And then essentially we can also start to look at then creating deliverables both within the GSLAM family with GSLAM Draw, but more importantly, and this is key for me really, is that as hardware maturity has happened within the scanning technology market, software maturity has been a bit of a lack. But we're at a point now where hardware technology is stable. We've come an awful long way since that commercialization process happened in the early 2000s to where we are now. Software is really starting to be key, and with so many more people using point cloud data and with lots of different software offerings, essentially GSLAM will make that data available to go into your application. I'm a strong believer of not reinventing the wheel with the customer. So if they already have an established methodology and workflow in terms of downstream CAD package, then we will do our best to get the data that we're capturing into that package for them to work with more efficiently. Proves your return on investment if I'm not teaching you how to use a whole different software platform when you can do that in your existing software. So as I mentioned earlier, we've got two main scanners that we work with here in the UK market. We've got the Revo RT, which is a slightly shorter range solution, a slightly lower density on our point cloud, but perfect for doing indoor mapping, small residential projects, that sort of floor plans, net internal area, used in conjunction with some of the accessories. We've got a really solid solution for that transition from maybe, dare I say it, sketching on site or using distos and tape measures and things like that. Very, very rapid to go in and capture, but giving you good quality, accurate data to work with. And then the sister scanner to the ZEB Revo is the Horizon, which is, as they class it, the ultimate mobile mapping tool. Much longer range. We're capturing data up to 100 meters from your walk line. You've got multi-application in terms of how we can use that. We can backpack mount it. We can mount it on a UAV, on an M300 drone. We can mount it on a vehicle, as well as obviously just use normal handheld application. So with all those different accessories, we've obviously got robustness in how we can approach a project. A complementary accessory for the Horizon was the launch of the ZEB Vision. Matt spoke a little bit earlier about photogrammetry applications, and we've sort of transitioned almost away a little bit from photogrammetry into the world of LiDAR, and actually we're seeing that photogrammetry information and 360 photos and spherical imagery actually now coming back into play quite heavily with LiDAR data as underpinning it almost. So the addition of this 360 camera option to the Horizon comparison, which was June last year, has been really, really exciting for us. And we're seeing people interacting with their data differently, having bubble views of the point cloud, being able to very quickly take that and digitize both from the image itself as well as from the point cloud data, and make sure very, very rapid in terms of turnaround of office deliverables. And then when we look at the accessories, so I said there's lots of different ways we can use the technology depending on what type of project. So using an extension pole can get you into confined spaces, down manholes, with additions of pano cameras, either through the vision for the horizon or from the pano for the Revo. We've got that addition of spherical imagery. So as we said, that accessibility of data is key. The easier you can work with your data, or the easier we can make data to work with, more people will start to use it and be able to interface with it and get more information out of it. And we've also got, for larger mapping projects, the ability to run the sensors in conjunction with a GNSS receiver, so with GPS systems. So great for environments where we may not have geometry to work with our SLAM, but we can still control that SLAM trajectory using GPS positioning technology. And then when we start to think about, well, what can we do with point cloud data? You know, the technology itself for the actual capture process is straightforward. We can capture data very, very simply, quickly, easily. The key then is what we do with that data, and making sure that both the data that we capture is relevant for what we're needing. As Chris said in his presentation, you know, data is this huge new resource that is actually a fantastic resource, but it also has its challenges. We can get incredibly data heavy point clouds where we've got too much information. So we've got to be able to have tools within the software that allow us to manage that heaviness in the data, make it accessible, make it transferable from one data format to another, make it transferable from one software platform to another. So the GeoSLAM Connect platform is there really as that transition from your raw data to preparing it to be able to then take into these third-party applications. So the GeoSLAM Beam is the key thing that we mentioned. So we've got this very, very strong algorithm which allows us to process quite complicated data. And that there is this unraveling process. So the handheld technology, being able to wander in and out of spaces, making sure we get visibility is obviously key from that. We can optimize, so this was quite a new feature with the software in terms of, depending on how you've captured your data, either the application, but also then the environment that you've captured your data in. We've optimized the algorithm so that we can be confident that the way we're processing the data is correct, and we're using the correct data. We're using enough of that point cloud that we've captured. So be it either a confined space algorithm or a tree-based, forest algorithm, or even on the UAV. So lots of different ways we can work with our data. And then we do also fit into that survey workflow, and this is key when we're linking into existing site control from a construction verification perspective, but also from a multi-sensor. We've got to be able to link into a larger site network or a global network of information, and we can do that very simply using what we call a stop-go georeferencing routine, where we capture commonality, common points that can be transformed into a site grid, be it local or, like I say, OS grid. And then the next key thing is this automation of cleaning of data. And this was a really big thing with data. Obviously, we're capturing information in potentially busy offices, congested road spaces where there's vehicles and pedestrians and other moving objects. So being able to start now cleaning our point cloud data is quite key for us. So being able to remove those unwanted points where there's noise and stripes and noise in the data, being able to clean up mobile data. So mobile data does have, like all data, like all LiDAR data, does have a degree of noise in there. So we want to try and make that, clean those point clouds so they're sharp, crisp and easy to work with. And also when we start to apply the 360 imagery, we want the cleanest data to be able to put those RGB points onto. So the filtering has made a huge difference in terms of the quality of GeoSLAM data. This little video will show the difference that we can see between that transient filter search, moving object filter. So it made a huge difference. And the key thing with GeoSLAM is that their strong focus is very much in that hardware technology, the complexity of that GeoSLAM algorithm to make the data process as robust as possible. But then at that point, we'd like to hand over. Like I say, we don't want to reinvent the wheel. There are offerings from GeoSLAM in terms of GeoSLAM Draw for doing 2D and 3D extractions from the point cloud data, but we also have a huge network of partners that we work with that will be able to take in GeoSLAM data. And that's key for us. You know, we want to be able to make point cloud data accessible. The more people who can interface with it, the more people will use the technology. And it's a really, really fantastic platform for working with. LiDAR does give you huge opportunity and we're seeing uptake of use in a whole different range of applications, be it, as I said, from MOD-based applications, from specialist search teams, through to we do an awful lot of work with Forestry Commission, universities who are in that geography space, so understanding carbon contents of trees and that type of thing, but as well as general sort of space planning, lease, net internal areas and things like that, and then your plans for your architect and design who were wanting to obviously look at doing renovations and redevelopments of spaces. But GeoSLAM, the technology itself, came out of a CSIRO grant, and mining and quarrying the underground market was actually quite a big sort of opportunity space for GeoSLAM to operate in. So being able to have that underground mapping capabilities, either autonomously by drone mounting it or vehicle mounting it for remote access, has become quite key. So we do partner with quite a few of the mining industry, so DESIC and obviously Micromine and the likes of that. So yeah, it's an interesting sort of diversion away from the traditional way of capturing LiDAR data, and like I say, the pure volume of space that you can capture so quickly, maintaining that a relative accuracy that's required for a lot of projects is absolutely key. But for us, we will see, I think, in the future, this sort of integration between tripod-based systems and mobile systems much stronger than it is currently. But I think that's certainly the adoption line that we're seeing people going along. Okay, and that's me done. So I shall pass the presenter baton over.
Thank you, Charlie. And note to say that DJI drones are also available from SurveyTech. So if you do want to mount your GeoSLAM on a drone, we can help with that integrated solution. And hopefully at some point we'll be able to, as you say, mix the tripod and the SLAM data even more. And I think integrating data sets and things is definitely something that we all look forward to more in the future. Phil, your screen's currently just blue. Oh, there we go.
Yeah, to go into present. Thank you very much. So yeah, thanks Matt for the invite for today to tell you all about Hexagon and Leica Geosystems and where we are in this sort of reality capture sort of world, really. But just a little bit of an introduction to Hexagon. Really, we're sort of a global leader in digital reality solutions, and our sort of strapline, if you like, is empowering an autonomous future. Yeah, so our vision is we want to fully autonomous leverage the industry for sustainable thrive. Our mission is to put data to work to enable autonomous connected ecosystems that boost efficiency, productivity, and quality for our customers. So, what does that mean in terms of reality capture for us realistically? Obviously, reality capture is at the core of the Hexagon Leica Geosystems business. We offer a variety of different technologies that capture the physical world, 3D physical environment, and bring that into a desktop environment. That could be terrestrial scanners that collect 1 million points per second, backpack solutions where you can walk through the environment, a bit like what Charlie mentioned, and kinematic solutions where you can capture data over long distance on moving vehicles, as well as UAVs to capture sort of world from above. We've kind of split this into 3 core main sections within reality capture. We've got the terrestrial laser scanning, the tripod LiDAR mounted systems, which are super accurate and collect a lot of data very quickly. through into what we call mobile mapping, which is MMS, which is the LiDAR sensors on a vehicle moving at speed. Clearly it shows it's on a car, but this could be on a train system or even on a boat. And then through to what we call the autonomous reality capture. So this is the dynamic moving objects to collect, the LiDAR sensors that collect in complex environments, basically. So we've got a whole host of portfolio of sensors, and I think obviously it'll be too short a time to try and kind of explain everything, but just a little bit of a broad overview of what we do. So, market leading terrestrial scanners. The BOK range is the reality capture for everyone. So if you've not got, great amount of experience and you just want to capture a space for whatever reason, then we've got handheld and tripod based systems that are very easy to use, through to flying laser scanners and UAVs, through to the more sort of experienced dynamic and mobile mapping solutions, but a whole portfolio of sensors. And just to maybe highlight, maybe our flagship sort of terrestrial scanner in this range is our RTC 360. And the unique thing about this is what we call a visual inertial system. So this tracks the scanner through a real world environment. So you can see on the example there that someone's transitioning through a building, and it's collecting lots of accurate points as it's moving through, and it's mapping this world in the real environment. And the little pixels that it's collecting is it's constantly checking those points for any movement, and is it a sharp edge in a corner, and that's how it's positioning itself in an environment. So you can pop out the other end of the building and it can be positioned, and clearly you need to then strengthen that with overlapping geometry and point clouds in the software. So sensor is a lot of the reality capture sort of aspect to it, but the workflow is more important to us realistically. So we're looking at not only sort of the capture stage, which is using all these different sensors and tablet-based systems and your smartphone to capture all this real-world environment, but then we progress into what we call the preparing stage. So this is where we bring the data into a desktop solution where you can do things like automatic cleaning of point clouds, removing of noise, which is cars and people, which I think Chris mentioned, and then maybe the coordination side of things, so the georeferencing, so you're getting a real big picture of what's happened on site, and then we kind of lock that down, and then we move into what we call a managed stage. So point clouds and 360 images, it can be a lot of data, so we need to find ways to easily share and manage that data. So that could be a file format which is highly condensed and reduced, which contains kind of everything that we're capturing, including metadata, through to what we call a Cyclone Enterprise, which is an online collaboration tool. So that the kind of the central source of truth, really, where we push all this data onto a server or onto a cloud-based solution, and then we can share that instantly with kind of key stakeholders. So that's a really important part of this whole process, is to efficiently manage and collaborate on this data. And then we're into and that's the generic workflow as we classify it, but then we move into the application specific, which is the delivering and the creation of something from that spatial data. Clearly point clouds and 360 images are very usable data in their own right, very measurable data, but sometimes we need to extract or fit something to that cloud, and we can do that in various ways. So Hexagon have a CAD solution called BricsCAD, and we can create 3D models, floor plans, elevations, sections, all that sort of standard construction type survey deliverables. But then we can look at a more sort of advanced deliverable into some software called what we call Cyclone 3DR, and then we do plugins that sit inside other manufacturers' software. So how do we handle our data in other solutions, something like SolidWorks, for example, or in an Autodesk environment. So depending on what sensor you use, it should be the exactly same workflow through preparing, manage, and delivering that data. So when you're looking at the actual extraction, you could probably speak hours about this sort of subject, and we're always problem solving within survey. and looking at the different deliverables, and just a few examples on the screen in terms of construction. So looking at construction verification, has it been built, has it not been built, where has it been built, that real-time checking of the data. Clash detection, clashing, anti-clashing is an important part of that construction process. And then we could look at the actual deviation analysis report. So, how far has it been built out of tolerance from a 3D model? And it could be, from smaller objects up to, the example on the screen is huge breaches and building structures. So very rapid way of detecting, how far out of tolerance it is, through to sort of floor flatness, verticality analysis. It's limitless and endless basically. And, there's a solution and a software out there to almost detect everything you need. Obviously more about the sort of problem solving deliverables. Like I said, BricsCAD is our sort of CAD package. So from the creation of 3D models in a BIM world through to mechanical and electrical engineering, as simple as the surveying deliverables, which is floor plans, elevations and sections, which is what people kind of want to use it for. But there's a collaboration tool for the construction industry. So again, it's all about sharing and collaborating on this data. We have an online platform at Hexagon called HXDR, or Hexagon Digital Realities. And this is a cloud-based collaboration platform it can be on a very grand scale, from huge Hexagon content, which is captured by our city mapper. So huge amounts of data on cities for all sorts of variable deliverables, but you can put your reality capture content in there, your CAD models, your OBJ models, and I think what Chris alluded to, it's all about sort of sharing and visual aspect to this data. So creating tours, and then people can really see what's out there without actually kind of visiting that site. So we've got tools that can handle all that. In terms of reality capture, a question we get asked realistically is, what are the opportunities? But the opportunities are endless, from the very basic common applications, terrestrial scanner capturing the data in a real world environment, to the more unusual applications of, a subsurface sewer system on a crawler system. So we have what we call a BLK ARC, which is the autonomous side. So this is a sensor that sits onto a robotic carrier and collecting that data as it's moving through that environment in real world. So yeah, so from the common to the unusual, the applications and opportunities that are endless. And then just a final slide on sort of BIM realistically. BIM's all about the people, the process and the technology, and it's rapidly growing as importance in construction sort of BIM projects. So the merging and the mixing of the data, the 3D spatial data, which is kind of the point cloud, the 360 images, the design models, all that has to be sort of brought together in one cohesive BIM project. So yeah, that was very short and sweet from myself, but I'll back across.
Thank you. Thanks, Phil. And yeah, it's really interesting to see how this technology, I mean, a lot of it starts in maybe survey firms, but then it does just sort of spread into lots of other different sectors. And I think we can really take a lot from that. And one of the questions that came in is what are some of the unusual applications? Now, Phil, I think you probably showed that really with the tunnel stuff. But have any of our other guests had any particularly unusual uses of their tech that they've supported someone with? Charlie?
Yeah, so I mean, the GeoSLAM is quite an interesting tool, and what Phil touched on it briefly in terms of the autonomy side of things. So with mobile technology, you can essentially mount it on lots of different platforms. So we're seeing them quite extensively now being mounted onto robotic vehicles. Obviously, there's the Spot the Dog, but there's also other wheeled devices out there, and then using essentially RF frequency radios. We can get 400 or 500 meters range on the equipment using, and obviously navigate to where we need to get to using video screens. So, video camera links. So we can actually start to go into those places that we wouldn't necessarily want to put either human beings or obviously from health and safety risk, explosion risk, things like that. So within both mining space, being able to go into areas where there may have been rockfall, but also obviously just general mapping. If you're unsure of the quality and the condition of the environment, if it's not safe for a human being to go down there, then we can use technology now to get into those applications. So Geostam's obviously lending itself massively in that side of things. But yeah, I suppose one of the big areas for Geostam in the UK is forestry, is under, tree mapping. So, and that comes down to carbon monitoring and carbon coefficients that are in certain tree spaces. So being able to understand how many, what trees, what species you've got in a quadrant area, you can then look at tree trunk diameters and then understand by that tree species and that diameter, we've got X amount of carbon in that, and then scaling that up on larger projects. So, Amazon rainforest, Gabon, places like that. So where there is, those big reserves of carbon, and how do we better understand them, know our volumes, but then also how do we manage and protect those environments?
And it's seeing trees, but also not seeing trees, because one of the big applications for drone-based LiDAR is being able to map the topography underneath the forest, because it's able to shoot through the canopy. Now, if you were trying to do a traditional topo survey through a massively forested area, it's basically a nightmare. So we find actually that the more we develop these technologies and use them, the more applications there are. Chris showed the Matterport Discover website with all the incredible spaces on there. But have you supported some more unusual customers?
Yeah, there is, and I think some of them, I mean, the ability to capture anywhere is really here. So how far can we push this technology to where we're going? I mean, there's spaces around the globe that are simply not accessible by the public. But you may want to show parts of them. One of the ones I always go back to are the pyramids at Giza, and somebody having taken a Matterport camera into the pyramid and actually scanned a lot of it. So, an experience that a lot of people might not get the opportunity to go through, you can kind of do a digital representation of that. So possibilities really are endless. I would say, we're always wanting to capture more and more. We want to capture it faster. We want to capture it more detailed. Those are the trends that we're all seeing. And I'm sure there are some newfound ways that we can push the box even further beyond robotics and drones to get there. We really are becoming an age of digitization, and the amount of data reflected in that first slide I had shown shows that trend's only set to go one way.
And what might be obstacles to overcome for people to use this technology, would you say? I guess Phil, maybe if you.
I think that in terms of reality capture, that there's a technology kind of for everyone really. We, at Hexagon and Leica, we've always got a kind of a good, better, best scenario. There's always an entry-level product if you just want to do a couple of setups somewhere in a room, or capture some sort of 360 imagery like Chris has got, or up to the high-end sort of mobile mapping systems and autonomous systems. There's something out there for everyone really. I think the key thing is kind of not to be scared about it, is to try and solve a problem with it. There's not such a thing as a sort of laser scanning project. It's how do we capture this data, and what technology do we use, and therefore what software do we use, and then what deliverables can we create. So try and kind of work it back really from the project, from the deliverables, and there's something out there for everyone to get started with.
I think that's a really good message to end on, is that with all of these solutions, that there absolutely is a best tool for the job. And if you come up with the thing that you need to be capturing, you need to think about the accuracy, the sort of space it is, and then you can work backwards from there. And you know, these products aren't just available for sale, they're also available for hire, and they can start off, you know, from the phone in your pocket right up to, you know, the super autonomous car mounted, drone mounted laser scanners. So it's worth just starting to think about how you can employ them in whatever industry it is. And with that, we're coming up to 1 o'clock. So I'd just like to really thank our guests, Phil from Leica Geosystems, Charlie Crock from SurveyMax, who was speaking about GeoSLAM, and Chris Atkinson, who gave us a great presentation and chat about Matterport. If you have any questions that we didn't get round to, and there are a couple in there, we'll take a look and we'll put them out in the mail out. But apart from that, thank you very much for joining us. And our next webinar will be on machine control. So we're moving through all of the different sort of technologies on this, and hopefully people find them very useful. So thanks very much to my guests and for everyone who tuned in. Bye-bye.